Today's lesson is covering 5.2 verifying trig identities. 5.2.3 is also the agenda for Friday, so we will only finish about 4 problems in this video. Guidelines for verifying trig identities are as follows. Step 1, work with one side of the equation at a time. We're almost always working with the left side of the equation, as the right side is what we want to simplify it to. However, there are occasions where the right side may be easier to work with. Part 2, look for opportunities to factor an expression, add fractions together, square a binomial, or create a monomial denominator. If there's any way we can switch the denominator from being something like 1 minus sine squared to cosine squared, that is typically the step that we need to do to be successful. In regards to squaring a binomial, if we have like 1 plus cosine of theta in the denominator, we want to multiply by 1 minus cosine, and that would be kind of multiplying by conjugates, which would be how we would square it. In order to get it to work for us. Step 3, look for opportunities to use the fundamental identities. If you see tan squared plus 1, or tan squared theta plus 1, that is a key that we probably want to use our secant squared identity in that situation. Same thing if we have 1 plus cotangent squared, then we want to use cosecant. And if you, for some reason, find sine squared plus cosine squared, of course, we're looking to just combine those and make them 1. Step 4, when preceding guidelines do not help, convert everything that you can possible to sine and cosine. Sometimes this will open something up to you that you didn't see in the first place, such as an example might be cotangent over cosecant. They both have sine in the denominator, and that simplifies to being cosine. Okay, and step 5, if you get stuck, try a different way. Try again. So maybe you start off by trying to add fractions and that doesn't work. Then you might look to see, well, maybe we can square a binomial, or maybe we can factor somewhere. Once in a while, it'll also help to, if you're really stuck, to try working with the opposite side of the equation, and that might make it clear that, oh, we're just like 1 or 2 steps away from getting to that value, and then you can just, again, continue from left to right. Starting off, number 1, secant squared theta minus 1 over secant squared theta equals sine squared theta. Now, as much as you may want to say, oh, this is 1 minus 1 over secant squared theta, that would actually leave you a little further away. It will still work, right? There's more than one way to do it, but in the method I chose to say, well, secant squared theta minus 1 is actually equal to tangent squared of theta. Now, when we have tan squared of theta over secant squared of theta, that will lead to rewriting it in terms of sine and cosine. Tangent is sine squared over cosine squared, sorry, tan squared, and secant squared is 1 over cosine squared. So as you see, they both have cosine squared in our denominators. When we multiply, we're going to get out, and it'll only be sine squared over 1, which is sine squared of theta. And in the end, that's what we were looking for. Now, as I earlier mentioned, you wouldn't want to do 1 minus 1 over secant squared. You could do that. That would still get you to eventually being 1 minus cosine squared, which equals sine squared. So there is more than one way to do it. And don't feel like your way is right or more correct or less correct than another. Obviously, you want to have the smallest number of steps, but if you find it in 6 steps and someone else finds it in 4, that doesn't make your way wrong. Next up is 1 plus 1 minus sine of x plus 1 over 1 plus sine of x equals 2 secant squared of x. Now, whenever you see these pieces in the denominator, we want to make this 1 minus sine squared by multiplying by the conjugate. Same old thing over here. The only difference between the two is on the left, we're going to multiply by 1 plus sine of x on top and bottom. And on the right side, we're going to multiply by 1 minus sine of x, because that will give us 1 minus sine squared in the end. Now, the nice thing is both will end up having 1 minus sine squared in your denominator, so we can just put it as one fraction. And once you see this spot, you're like, oh, okay. Hopefully you see that the denominator is going to become cosine squared, and in the top, sine of x's, we've got 1 positive, 1 negative, those will cancel out. All right? And then we're going to be 1 plus 1, which equals 2. Really difficult math there. 2 over cosine squared of x equals 2 secant squared of x, right? 2 times 1 over cosine squared becomes 2 secant squared of x, and that's all you do with that one. A little more straightforward on that one. Next, number 3, tan squared of x plus 1, quantity of that, times the quantity of cosine squared x minus 1 equals negative tangent squared of x. Okay. On this side, tan squared of x plus 1 looks a lot like secant squared. And cosine squared of x minus 1 is minus sine squared of x. We covered this similarly in an earlier lesson, but just showing you, going from sine squared of x plus cosine squared of x equals 1. If we move the 1 by subtracting 1 to the left, and then we subtract the sine squared x to the right, we end up with cosine squared of x minus 1 equals negative sine squared of x. So you'll notice our left side matches, so negative sine squared of x fills in right there. Now these two multiplied equal negative tangent squared of x, but you do need to show more work than that because that's not a common knowledge part. Once you change secant squared of x to 1 over cosine squared of x, and we still have the negative sine of x there, it becomes negative sine squared of x over cosine squared of x, which is the same thing as negative tangent squared, right? Sine over cosine is tangent, so sine squared over cosine squared is negative tangent squared. Sorry, tangent squared of x, and the negative just follows suit. Last one for this lesson is cosecant of x minus sine of x equals cosine times cotangent of x. First step of this one would just be to rewrite it in terms of sine and cosine. Sine of x is already there nice and neat, and then on the left side we've got 1 minus sine of x. And so what we're going to do is we're going to multiply this right side by sine of x over sine of x so that we can combine, and we'll just make this one piece instead of 2 separate pieces. So once we have a common denominator here, we end up with 1 over sine of x minus sine squared over sine of x, which gives you 1 minus sine squared of x over sine of x. Once we're seeing the 1 minus sine squared, that should click right away that is cosine squared of x over sine of x. And then this is just some fancy separating. Basically, cosine squared is cosine times cosine, and then we'll leave the sine of x down there. This could technically be cosine of x over 1. You can split it up that way, and cosine of x is just going to be cosine of x, whereas cosine over sine becomes cotangent. So basically, we have an extra cosine with our cotangent, and that is our correct answer.